Last time we started section 2.3 where we were looking at other set operations. And I believe that we are on example 2, part C. So just as a reference point for where we had finished up in section or in part B of this problem, we're working with these different sets. When we have two sets, they have two overlapping circles, three sets or three overlapping circles. We designate the different sort of areas of the graph by numbers, and then we're able to identify which numbers satisfy which are the pieces of the criterion, do unions and do intersections and so forth, and then once we get our final answer, like this at the bottom was 2, 4, 5, 6, and 7, we can go back to the diagram and we can shade those regions. So we're going to do another example here with 3 circles. So since it has 3 circles, we start by drawing 3 overlapping circles inside of our diagram, something like that, and labeling them. So we have A, B, C, and then the box on the outside is the universal set. Better. And then we use our placeholder numbers. That's really all they're doing for us, is holding the places. 1, 2, 3 across the top, 4, 5, 6 across the middle, 7 on the bottom for C, and then 8 on the outside. And there's nothing special about these numbers. I mentioned, and I'll mention it again, that when you get to the group work and homework, the diagrams don't even always have 3 circles that overlap. Sometimes they draw the circles differently, and then you can just use whatever numbers that you need in order to fill the spaces that you have. And you can do the same thing. We're just making it as complicated as it could be, so as a reference point. All right, so we're going to start inside the parentheses. And on the inside of the parentheses, notice that we have an A and a B complement. So first we will look inside circle A and list all the numbers that are in A. So what numbers do you see in circle A? 1, 2, 4, and 5. Everybody okay with that? Good. B complement means all the numbers that are not in B. So what numbers are not in B?
1, 4, 7, 8.
Okay, is everyone okay with that line? Okay. And then what it says we want to do is that we want to join these with that symbol here. What is that a symbol of? You remember?
Intersection.
The intersection. An intersection means what they have in common. So looking at the sets of numbers in A and B complement, what numbers do they have in common?
1 and 4.
1 and 4. So we're going to list here 1 and 4. Okay. Now we've done everything inside the parentheses, so we move to the outside of the parentheses. Outside the parentheses, you'll notice that we have an additional complement set, C complement. So what numbers are not in C?
1, 2, 3, 8.
Good job. Everybody good with that? Okay, and so we're going to take A intersect B complement, and what symbol comes next? Yep, and we want the intersection with C complement. So these last 2 lines that we have, A intersect B complement and C complement, we want to look for what they have in common again. So what do they have in common? 1. And remember we talked about before, and we actually had examples of before, just because there's 2 set operations doesn't mean they have to be the same. This one was. They're both intersections. But over here, we had an intersection and a union. So you just need to pay attention to the question that's posed to you directly. So the only number that they overlap for is the number 1. And then we would go back to our diagram and shade region 1. Is that all right with everyone? Okay, all of that is actually building to these last, I think it's 4 problems. These last problems actually show application of what's going on, especially the next 3. And so we need just a little bit more building up with example 3, and then we have the application problems for 4 and 5. So when we put these numbers in here, we were just using them as placeholders. And there's nothing special about the numbers we chose. They were just the first 8 numbers. There's nothing special about where they went. We just put them there, right? We could have used letters. We could have put them in a different order. None of that's relevant. But when we take a look at what's going on in example 3, and then we'll do 4 and 5, the values that we have are not placeholders. They're actually the number of items in that category. Right? These are each sets. So when this says in parenthesis A close parenthesis equals 24, it's telling you that the number of items in that circle A add up to 24. Okay? So we do have three sets given here, A, B, and C. So we do need a diagram that starts out having 3 overlapping circles. So that part's like what we did before. So go ahead and take your diagram, draw in the 3 circles. So we have A, we have B, we have C, and the universal set on the outside. We're going to start by taking a look at this at the very first thing listed. The number of items in A is equal to 24. So circle A is all of this area, right? It's all of that. And what I hope that you noticed when I did that is that there's these 4 different regions. 1, 2, 3, 4. There's 4 different places that all have to add up to 24. The reason I mention that is while it's listed first, it's not a good place to start. Because if you decide to start there, you've got to use trial and error to continue going. And trial and error, taking the number 24 and splitting up into 4 places, is going to take you a while. And it's not going to be fun. This isn't a Sudoku kind of fun. It's just going to be really annoying, and you're going to be like, seriously? Okay, so that's not a good place for us to start. We will not start with the first pieces of information. So let's ignore them. And if I'm ignoring n of A is 24, I'm going to ignore n of B and n of C for the same reason. Right? They encompass 4 regions. Now, the next 3 are a bit better. This says A intersect B. So A intersect B is this sort of football shape right here, right? But again, I have 2 regions in which I have to add up the numbers to get to my 10. So it's not as bad as 24. But still, again, I've got a lot of trial and error. I could 0 and 10, 1 and 9, or 9 and 1, or 8 and 2, or 2 and 8. Got a lot of options. I do not want to start there. And if I don't want to start with A intersect B, then I don't want to start with B intersect C or A intersect C as well. But the next one's quite helpful. This piece right here says that I have to intersect A and B and C. Where is that? The very middle. Now, they don't always give you one that looks like this exact description. Sometimes it's a different intersection location, but the verbiage, right, the language surrounding it will help you to know which very specific region there is. One of the pieces of information that you're going to get in a list like this is going to tell you a specific number to put in somewhere. It's not going to have lots of regions. For us on this one, it's the center and it's 6. Now, it's fairly nice that we had that 6, because what that allows us to do is it allows us to move back up to the 3 that I just skipped. For example, A intersect B, which I'd shaded before as being this region, has to add up to 10. But I've already got 6 of them written in. There's no trial and error. There's just subtraction. What's missing in the other piece of the region, A intersect B? 4. So I can put a 4 right here. I can do the same thing with B intersect C. B intersect C is this piece. Has to add up to 8. What's missing? 2. And the last intersection where it doubles is A intersect C, which is over here. It's supposed to be 15. How many am I missing? 9. And I'm sort of highlighting as I go so that we've kind of marked it off, kind of like a checklist. We've taken care of all those pieces of information. We've used them. So far, so good? Now, the good thing about that is that that leads us up to, we've got 3 things on the very top, and we've got this one at the bottom that's the N of U. N of U means all the 8 regions together. So that's going to be our very last thing that we do. because I've still got the outside of A, the outside of B, the outside of C, and the outside of the circles. 4 different places that I need numbers. But I can look at these individually. So A, circle A, which I mentioned before, is all of these, which is 4 regions, right? Everything that's highlighted in yellow is inside of circle A. So I've already accounted for the 4, the 6, and the 9. How much is that total? 19. And if there's supposed to be 24 total in this circle, how many are unaccounted for? 5. So I need a 5 on the outside of this, and now it adds up to 24. I can do the same thing for circle B. This is all circle B. I've got a 4, 6, and 2, 12. It's supposed to be 24, so how many am I missing? 12. Last one is circle C. All of this is supposed to add up to 26. How much is there so far? 17. So how many more do I need to make 26? Yep, it's 9. Okay, we've highlighted everything that we've been given except for one fact. That's the universal set. And the universal set is not the stuff that's on the outside of the picture. It's the stuff that's in the entire picture. So all the numbers that I have on there so far, plus the missing number out here, have to add up to 50. So we need to figure out how much is here so far. I have 5, 4, 12, 9, 6, 2, 9. I got lots of numbers. So add those together, and how many do you have? 47 is right. And I'm supposed to have 50, so how many are missing? 3. Now all of the regions actually add up to what I was hoping for, namely 50. Okay, so process of elimination, we're filling in pieces so that there's no guesswork allowed. I shouldn't say allowed, but no, not necessary anyway. It's not necessary. Okay. So now we can actually do application problems with this in mind. The first thing we do when we're looking at an application is we need to figure out how many different categories are being described so that we can draw the right number of circles. So we've got Joe Long. Joe Long works on albums for musicians. Last year, he worked on a total of 12 projects. He wrote and produced 2, he wrote 5, and he produced 7. Okay? First thing we need to decide is how many circles are going to be in this diagram. It's 2. What are the 2 categories? Wrote is one category, produced is the other. Those are the only 2 distinguishably different features it mentions. So we have 2 circles. I don't have space on my screen, so I'm going to work over here, and then we'll shrink it in a minute and pull it back over. But you've got space at the bottom of your paper. So we're going to have 2 overlapping circles. And you're welcome to just write into the circles what they're representing, right? One of them he wrote, and the other he produced. And this is the universal set. Now taking a look at the 3 pieces, actually I think it's got 4 pieces of information I'm given, is he worked on 12, he produced 2, he wrote 5, he produced 7, sorry I said wrote and produced 2, my bad, and then wrote 5 and produced 7. Which of those pieces of information is the most helpful place to start? And the reason is the word and, right, Hannah? Wrote and produced means it's an overlapped piece. So in my overlapping region of wrote and produced, I have a 2. Does that make sense for everybody? Okay, so I've done this one. What could I do next?
Put 3 in wrote, I think.
Okay, good. So we can move on to the wrote category. And you're exactly right, Percy. We can put a 3 there, because now the 3 and the 2 that are on the diagram add together to be 5, which is how many he wrote. So we've done this one. Now what? Produced. He produced 7 total. So we need a 5 out here because there's already 2 accounted for in the middle. Now there's a total of 7 in the produced circle. So the only piece of information we haven't done then is the working on 12 projects. How many of our projects are accounted for already in this picture? 10. There's 10. Does everybody see 10? Add all the pieces. So how many am I missing? 2 projects. So he did something else on those projects. Maybe he edited. Maybe he actually was participant in the music, right? Maybe he sang or something, or he played an instrument. We don't know. But he did something else on those projects. And so we have our 2. All right, so we're going to have our diagram right there. That's not too bad. Once we've drawn our diagram, we're actually able to answer the questions pretty easily. Questions come very directly from your diagram. It's really important that you both answer the questions correctly and draw the diagram correctly, but if you mess up the diagram, say like on a test or on your homework, if your answered questions match the messed up diagram, you don't miss the points on the answered questions because you understood how to interpret your diagram, even if you made mistakes doing it. Does that make sense? It's like partial credit stuff, right? Like I'm going to follow your mistake through. So you want to use whatever your diagram is as you answer those questions. So part A says, how many projects did Joe, he, write but not produce? 3. It's that outer region. How many did he produce but not write? 5 in the outer region. And how many did he neither write nor produce? 2. And that's on the very outside. Okay, any questions on that? All right, taking a look at number 5. We've got a youth group. Got lots of information. They're asked questions regarding songs they learned as children. Upon surveying the 34 youth, the following were obtained. 15 had learned Jesus Loves Me. 19 had learned the Bible. 28 had learned This Little Light of Mine. 13 had learned Jesus Loves Me and This Little Light of Mine. 15, Jesus Loves Me and the Bible. 14, the Bible and This Little Light of Mine. And 13 had learned all 3. Okay. First, we have to decide how many circles we need in our diagram. 3, all right? And what are our 3 circles? Actually, let me see if I have space over here. I do. The 3 different songs, right. So we have our 3 different songs. And I'm going to do them sort of in the order that they sort of show up in that list. Jesus Loves Me is the first one. I'll abbreviate by just writing Jesus. The Bible was next. And then the last one, This Little Light of Mine, so we'll write just light. And we have our universal set on the outside. Okay, is that all right? Okay. What piece of information here is the most helpful place to start? The last one. The 13 had learned all 3. Where will that go? In the middle. All right, so far so good? All right, what would you like to do next?
15 learned Jesus Loves Me.
Okay, 15 had learned Jesus Loves Me right here. Whoopsie, sorry. Here?
Yeah.
Okay, so the problem with starting there next is that I still have 1, 2, I meant to do this. 1, 2, 3 places that I'll have to add up to 15. So don't probably want to start with the 15 Jesus Loves Me just yet. What else could I start with? Okay, so this is the one that Hannah's suggesting. 13 learned Jesus Loves Me and This Little Light of Mine. So in our circle, Jesus Loves Me and This Little Light of Mine are these 2 pieces, right? They have to add up to 13, and there's already 13 in the middle. So what does that tell you? 0. And 0 is a perfectly fine number to put in any of these categories. You can have a 0. You can't have a negative, but you can have a 0. Because remember, these numbers actually represent, in this case, a person. No negative people. I mean, literally. Okay? Okay, So we've taken care of the 13, Jesus loves me, and this little light of mine. What's next?
You have the Bible.
Sure. So this 14 was the BIBLE and this little light of mine. So over in our diagram, that's this piece. They're supposed to add up to, say, 14. I've already got 13, so how many am I missing? Just one. So there's a 1 right here. Okay, looking good, getting things filled in. Now what? Yeah, the Jesus loves me and the BIBLE are supposed to be 15. That's this piece. So I need 2 in the upper corner there, 2. Okay, we've got 4 of our 8 regions filled in. That's a good start. Now we can go to the 15 Jesus loves me that we wanted to do earlier. 15 Jesus loves me is all of the Jesus loves me circle. So there's 0 in that outer category. Okay, again, zeros are perfectly fine. Okay, now what? Sure. So 19, the BIBLE. So this whole circle is supposed to be 19. How many are there already? 16. So how many are missing? 3. 3 go out here. Okay, and then what? 28 had learned this little light of mine. So this whole circle, 28. How many are there already? 14. So how many are missing? 14 in that outer region. Okay. It feels like I've marked everything off, but there is a piece of information I have not. What have I not marked off? Yeah, the 34 youth, right? This whole picture has to encompass 34 teenagers. I don't know how many are there right now, but we need there to be 34. Yep, Percy? You think there were only 1? Did you add them up and we got 33? Okay, great. Then yes, we'll have only 1 right here. And that will be our 34. Okay, is everybody good with our diagram? Okay, once we have the diagram, we're able to answer the questions. Now, the questions posed are a little bit different on this one because I wanted you to see some different kinds of things that can show up. This one says exactly one of these songs. So what categories? I mean, where are the exactly one locations? Yeah, the outer parts of the circle. The 0, the 3, the 14. Does that make sense? So as I'm writing these down, it's kind of helpful to me or whoever is grading for you to write down that this is 0 plus 3 plus 14. So if there's a mistake, we can figure out what it is you're mistaking the description to be. So what is 0 plus 3 plus 14? 17. How about at least 2 of these songs? Okay, so what did we add up? All right, all the overlapping pieces, they either overlapped with 2 circles or overlap with all 3. All right, that's the phrase at least 2. So 2 plus 0 plus 13 plus 1. And that's the 16. How about none of these songs? That's the one that's on the outside. And how about this little light of mine only? That's the 14. Okay, any questions on that? All right, we mentioned one other thing last time besides the unions and intersections that we've seen sort of happening in these descriptions. And that was the set operation of Cartesian product. Looked like this. It took items in one set and items in another set, and it made all the possible pairings. Remember doing that? And we wrote them as ordered pairs. So that's what this last question is actually going back to. It says, is the Cartesian product commutative? So commutative means that when we change the order, it's actually the same. In other words, the question says, is A cross B equal to B cross A? That's what it's asking. So I'm going to flip back to our screen before so you can see what the difference is when we change the order and then decide whether or not they create the same items. So over here, we had set A was XYZ, set B was 1 and 2. And when I did A cross B, we got X1, Y1, Z1, X2, Y2, and Z2. If we had done these in the reverse order, B cross A, what kinds of things would we have gotten instead? We would have gotten 1X and 1Y and 1Z. And what else?
2x, 2y.
Yeah. Are those the same ordered pairs? They're not. And basically what it boils down to is the fact that x1 and 1x are not representing the same quantity, value. It's easy to think about it in terms of an ordered pair in our Cartesian coordinate system, like the number line system that you know, right? So they are not the same. And an example from that number system, you could certainly use the example I just created as well, is that if you took an ordered pair 1, 3, this is not the same thing as the ordered pair 3, 1, right? They mark a different location in space. So that's an example of one showing why it fails. And it would fail on every single ordered pair unless they happen to be like with your Cartesian number systems, things like 2, 2 already. If you reverse 2, 2, you get 2, 2. Okay, that's good, but that's unique. That's not going to happen all the time. Any questions? All right, you guys have a little over 15 minutes today.